everybody. All right, today we're going to get into some overlapping sets. We'll probably stick with the two category sets for today. One of the things I want to go through, do some fraction-based set problems, maybe do some that involve algebra, and we can see where we're at. We'll have to do a slightly quick one today, but we have about 30 minutes here. So let me get open what I want to work on. Sets, you know, we teach using the table a lot. There's also, of course, the Venn diagrams. I tend, for two category sets, to just use the table. And when we're dealing with three categories, that's when I start to use the Venn diagram. These can also be somewhat formulaic, but again, I usually do stick to the table here. I find it to be the easiest way to organize the information and stuff like that. So just getting the first one open here. And give me a sec. All right, so first one is this. Okay, so I'll give you guys a couple minutes. Do the problem out, put your answer in the chat box, and we'll talk about it. So you can start now. All right, let's see what you guys got here. Okay, great. Mostly right answer, well, pretty much all right answers. So key with this problem, or at least in my opinion, we have the peanut people, the no peanut people, the total, got males and females. Now, you can use fractions here and then the total. You can use fractions here if you want, but I actually think a good way to deal with this question is to get a smart number, but that smart number can't be 100. It's got to be something that's divisible by 5, 8, and 2, right? So 40 is a wise number to use, then you just go through it. So 2/5 of the passengers are female. That's going to be 16. That leaves us with 24 males. 1/8 like peanuts, so that's 5, 35 who don't. Half of the male passengers, 1/2 of the passengers are males who do not like peanuts. So males, no peanuts is 20, then you can just fill in the rest. And now we want to know what fraction of the total number of the number of male passengers who like peanuts. So male peanuts is going to be 4. It's like an 11, that's 4. What fraction of the total male passengers? That's 24. Make sure you don't do it of the total number. That's a trap. So 4 over 24 is 1/6. So it seems like everyone was good there. All right, good stuff. I want to get into some algebra now. Take a look at this one here. All right, so I see some correct answers, some not. So this is one where we're going to have to plug in real smart number as well. So we fill it out, jacket, no jacket total, tie, no tie total. All right, so we can say 100 is the smart number here. 40% are doing both, so we can say 40, because 0.4 of 100 is 40. Now, here's the tougher part. 50% of the guests who wore jackets. We don't know the number of jacket wearers, so we're going to call that J. But we know 50% of them also did not wear ties, so that's going to be 0.5 J. Although something doesn't look right here, so let me just make sure here. 40%, 50% of the guests who wore jackets. Let me make that a J here. Okay, and we want to know what percent of the guests wore jackets. So we need to figure out what J is. Sorry, did not wear ties. No tie is here. This is no jacket. I knew something was off. All right, now we're good. So what we do is we take this and we just build an equation with it. Yeah, fixed that. So we take this, here's our equation. 40 plus 0.5j is equal to j. 40 is equal to 0.5j. 80 is equal to j. And that's our answer, 80% E. Yeah, that's how you deal with algebra. I want to do one more here, actually, but that's a really good example of algebra with overlapping sets. All right, let's take a look at this next one here. All right, I see some mostly good answers here. Did you guys find this to be the same level as the last one? Any easier? Any harder? I'm just curious because I'm wondering if because we did the last one, this one seemed easier, if that's not necessarily the case. Yeah, a little bit longer. And remember, they can give you problems with multiple variables in the chart too, where you would have to come up and just deal with multiple, you'd have to come up with multiple equations, and that's totally fine. That's, pretty normal, in fact. So just keep that in mind. There's different, there's kind of different components of these types of problems as far as algebra is involved. Now, usually it's just a single variable, but like I said, sometimes there can be, multiple, so just keep that in mind. So in a question like this, we've got GIF, no GIF total, male, female total, and then once again, we fill in. 300 guests, 70% brought gifts. Okay, so that would mean that's 210. That means 90 did not bring gifts. Now, 40% of the females brought gifts. So F is the females. Female gift is 0.4F. That would mean male gift is 0.6F. And then this, of course, is no, that's not 0.6F. What am I talking about? That's just nothing. That's 0.6F. 48 males did not bring, so 48 no gift. Again, we have our equation here. 48 plus 0.6F is equal to 90. 0.6F is equal to 42. So F ends up being equal to 70. Now, of course, that's not the answer. We want to know how many females did bring gifts. So female gifts is 0.4 of that, 28. So, of course, always be careful with the trap there, those trap answers. That's something they like to do because you see the thing pop on the screen. You say, oh, I have it. And then all of a sudden, you won't know because you're just in the middle of your test. You're going to be thinking you got it right when perhaps, you didn't. All right. So let's keep cruising here. I want to do one more, then we can chat. If you have any random questions, we can chat about that before we hop off in about 10 minutes. So the last one I want to do is find this here. This one here. This is the min-max question. All right, take a look at this. All right, so I see some differing answers here. So let me show you my process for dealing with max-min questions. So we've got we could say red on the top, no red, total, sunroof, no sunroof, total. All right, 3,000 cars here. 1,200 are red. And then, of course, 1,800 are not red. 1,400 have a sunroof, which means 600 do not. Now, at least 500 of the cars are red and do not have a sunroof. Not red, no sunroof. So no red, no sunroof is here. We want to know greatest number that could be read in sunroof. So we want to max out this, and this is just a big flow chart. That means we minimize this, and we then max this out. That's how this works, because you're talking about sums. So to do that, the biggest thing isn't 800. It's actually 1600, because we got to go with the smallest total value. That drops this to 200, and then this simply becomes 1200, and that's the max value. So you got to be really careful, not only in how you approach this, but also how you interpret it, right? Because it's possible that, you know, if you miss the word max, then yeah, you're going to struggle with, you know, answering this correctly, of course. But if you see the word max, you also have a process dealing with it, then yeah, you're pretty much good to go. All right, cool. So we're good. Any questions from anyone about anything here? Any of these? Anything we did today? You're studying in general. We have a couple minutes. Do you guys have anything? All right. Well, this was good, everybody. Good work. We'll be back next week. Maybe do stats or something. I don't know. We'll do a different topic, I'm sure. No, we can't. So, yeah, we'll do more of these. If you guys want more of these questions, we have tons of them in TTP. So, by all means, jump into our sets chapter. It's awesome. And we've added a couple more lessons in the last couple months. So, it's been pretty great. But thanks for coming, everybody. Good work. Glad we got through some good stuff. And yeah, we'll talk next week. Reach out if you need us, okay? Talk to everybody soon.